So we want to resolve this algebraic problem. We have x plus y equal to 5, and we have x to the power of 5 plus y to the power of 5 equal to 275, and we want to find the value of x times y. Solution. Let's name this equation 1 and name this equation 2. So from equation 1, our y will be equal to 5 minus x. Let's call it equation 3. So we'll be substituting the value of y into the second equation. Substitute the value of y into equation 2. So we then have x to the power of 5 plus, remember our y is 5 minus x. We then have 5 minus x all to the power of 5 equal to 275. So we can call this equation 4. But then from here, this is a binomial expression, is a polynomial expression. So, and its expansion, binomial expansion of 5 minus x all to the power of 5x. So we have 5 minus x all to the power of 5 to be equal to 5 to the power of 5 minus 5 times 5 to the power of 4 times x plus 10 times 5 to the power of 3 times x to the power of 2 minus 10 times 5 to the power of 2 times x to the power of 3 plus 5 times 5 times x to the power of 4 minus x to the power of 5. So this is a binomial expansion of this expression. So if we expand this further, 5 to the power of 5, that's 5 times 5 times 5 times 5 times 5, will give us 3,125 minus 5 times 5 to the power of 4 will give us 3,125 times this x plus 10 times 5 to the power of 3 is 125 times 10, 1,250 x squared minus 5 to the power of 2 is 25 times 10. We have 250 x to the power of 3 plus 5 times 5 is 25 x to the power of 4 minus x to the power of 5. So this expanded form, we are going to be substituting it into equation 4. So this will become, now equation 4, this is x to the power of 5 plus, remember this is the expanded form we want to replace with this. This will be plus 3,125 minus 3,125x plus 1,250x squared minus 250x to the power of 3 plus 25x to the power of 4 minus x to the power of 5, all equal to this, equal to 275. Looking at this equation, we have positive x to the power of 5 and we have negative x to the power of 5. So this will cancel out, and then we'll rearrange these figures. So cancel out x to the power of 5 and rearrange the terms. So this will give us 25x to the power of 4 minus 250 x to the power of 3 plus 1250 x squared minus 3125 x plus 3125. This 275 crossing over, we have minus 275, all equal to 0. From this equation, we have our highest power of x as 4. So we can be splitting these figures. So from here, we have 25 x to the power of 4 minus 250 x cubed plus 1250 x squared minus 3125 x plus 3125 minus 275, all equal to 0. So we are going to be dividing through by 25. Divide by 25. 25x to the power of 4 divided by 25. We have x to the power of 4 minus 250 divided by 25. We have 10x to the power of 3 plus 1250 divided by 25. We have 50 x squared minus 3125 divided by 25. We have 125x plus then 3125 minus 275. This will give us 3125 minus 275. This will give us 2850 equal to 0. So we'll still divide this by 25. So this will give us x to the power of 4 minus 10x to the power of 3 plus 50 x to the power of 2 minus 125x plus 114 equal to 0. Remember, we divided this by 25. Hence, from this equation here, we will be splitting each of these numbers into 2 in order to make this equation factorizable. So we have x to the power of 4 minus 10 can be splitted into 2 to have minus 3 x to the power of 3 minus 7x to the power of 3 plus 50. We split it into 2. We have plus 21x squared plus 29x squared minus 125 splitted into 2. We have 87x minus 38x plus 114 equal to 0. So let's have x to the power of 4 minus 3x to the power of 3 minus 7x to the power of 3 plus 21x squared plus 29x squared minus 87x minus 38x plus 114 equal to 0. Let's factor out the common values. There is x to the power of 3 and there is x to the power of 3. So we have x to the power of 3. We then have x minus 3 minus, from here we can factor out minus 7x squared. So we have minus 7x squared. We have x minus 3 plus, we'll factor out 29x we have x minus 3 left. And from here, we'll factor out minus 38. We have x minus 3, all equal to 0. So this is unique for each of the values. So we then have x minus 3 times this. We pick all the terms outside the bracket. We have x to the power of 3 minus 7x to the power of 2 plus 29x minus 38, all equal to 0. So this simply means we have a linear equation and we have a cubic equation, but we can still reduce this cubic equation into a linear equation and a quadratic equation. So let's have x minus 3. We can write this as x to the power of 3. Splitting this minus 7 into 2, we have minus 2x squared minus 5x squared, plus splitting the 29 into 2, we have 10x plus 19x, and we have minus 38, all equal to 0. So from here, we have x minus 3, we have x to the power of 3 minus 2x squared minus 5x squared plus 10x plus 19x minus 38, all equal to 0. So you have x minus 3. Let's factor out x to the power of 2 from here. We have x squared, x minus 2. Factor out minus 5x. We have x minus 2 plus, and factor out 19 from here. We have x minus 2, all equal to 0. So from here, we have a similar term in the brackets, which is x minus 2. So we factor it out. We have x minus 3 times x minus 2 and x to the power of 2 minus 5x plus 19, all equal to 0. So from here, we have a linear equation, and a quadratic equation. This simply means that x minus 3 is equal to 0, and x minus 2 is equal to 0, and x to the power of 2 minus 5x plus 19 is equal to 0. So we'll be resolving this separately, resolve this and resolve this. So from here, we have x equal to 3, and from here we have x equal to 2. So we have x to the power of 2 minus 5x plus 19 equal to 0. So our A is equal to 1, B is equal to minus 5, and C is equal to 19. While our x is equal to, the quadratic formula is minus b plus or minus square root of b squared minus 4ac all over 2a. So this is equal to our b is minus 5. So this is minus 5 plus or minus 5 all squared minus 4 times 1 times 19 all over 2 times 1. So minus times minus will give us positive 5 plus or minus 5 to the power of 2 is 25 minus 4 times 1 is 4, 4 times 19 is 76 all over 2. So this is equal to 5 plus or minus 25 minus 70 is 6 minus 5, 1. 7 minus 2, 5. That's minus 51 all over 2. Means that x for this quadratic equation is not a real solution, not a real solution, because this will give us 5 plus or minus I root 51 over 2. So this is not a real solution. So we'll then work with the first solution we got as x equal to 3 and x equal to 2. So remember the question. The question says x plus y equal to 5, x to the power of 5 plus y to the power of 5 equals to 275, and we are asked to find xy. So we want to find xy from here. So when x is 3, from equation 1, x plus y equal to 5, it means that y will be equal to 5 minus 3. So y is equal to 2. And when x is equal to 2, we then have y equal to 5 minus 2. So y is equal to 3. Hence, our x, y will be equal to 2 times 3, which is equal to 6.